Find the domain of f of x equals x plus 1 over x cubed minus 4x. Well, remember that the implied domain of a function is the set of all the values of x, or the input values to the function, that produce a real number output. And so we have a couple of operations on real numbers that do not produce real numbers. First we have square roots of negatives. Those give us complex numbers. And we have division by 0, which doesn't give us an answer. We don't have any square roots in this problem, but we do have some division. And so what we're going to need to look at to find the implied domain for that function is the set of x values that make the denominator 0, and then we're going to have to exclude those. So let's consider that denominator. We have x cubed minus 4x. Well, that's equal to 0 when, well, first we can factor and get x times x squared minus 4. So it's equal to 0 certainly when x is equal to 0, because then we'll have 0 times negative 4, which is 0. But we can go a step further, right? This term, or this factor, can also be 0. That's true when we have, well, x squared minus 4 is a difference of squares. We write that as x plus 2 times x minus 2, breaking apart the difference of squares. And so now we can see that we have three ways to get a 0. We can have either x equals 0, or we could have x plus 2 equals 0. Of course, that means that x equals negative 2 gives us 0. Or x minus 2, this factor could be 0, and then we'd have a 0 product. And so if that's 0, what we're looking at is an x equal to positive 2. So the three zeros of the denominator are 0, negative 2, and 2. And so when we restrict our domain, we're going to need to make sure that on the real number line we stay away from 0, 2, and negative 2. Those numbers, when input into this function f, are going to give us division by 0, and therefore won't produce real numbers. And so those numbers, negative 2, 0, and 2, need to be excluded from the domain. Okay, so we can write that as an interval, or a series of intervals. Let's write negative infinity up to negative 2. That's all of this part of the number line. Those should all be okay. Together with negative 2 to 0, that's all of these, not including the negative 2, not including the 0. Union together with the stretch from 0 to 2, that should be okay as well. 2 is a problem, but then one more union from 2 to infinity gives us all of the real numbers that are in the domain of f. It may also be simpler in this case to write the domain of f as a set. We can simply write the set of all x such that x is not equal to 0, x is not equal to 2, and x is not equal to negative 2. And that also is another way of describing the set of real numbers that can be used as the domain of f.